Hi everyone, I am Vipin Kumar, founder of RPN Tutorials. Welcome to my channel. Today I am going to talk about rational and irrational numbers. Rational numbers are those numbers which can be expressed in the form of P by Q, where Q is not equal to 0. For example, if we take the number 1 by 2, 1 by 2 is a rational number because it can be expressed in the form of P by Q, where P is equal to 1 and Q is equal to 2. And 2 is not equal to 0, therefore this is a rational. Likewise, say for example you take 4, 4 is also a rational number because it can be expressed in the form by 1 and where 1 is not equal to 0, so therefore this is also a rational number. Okay. Now there are two types of rational numbers. One is terminating rational number, another is non-terminating recurring rational number. What do we mean by terminating rational number? Suppose the rational number is 1 by 2 and you want to find the decimal form of it. So what you will do? For 1 by 2, you will divide 1 by 2. Okay. So there will be 1 0 and therefore there is one decimal, and then 5 ja, and this is 10, and ultimately this is 0, this is 0. Okay. So the remainder is 0. It means it terminates, and the value is equal to 0.5. Okay. So terminating means when you divide the numerator by denominator, ultimately there will be a remainder which will be 0. In this case, we got it in one step itself. In other cases, like say 7 by 8, you will have to repeat the steps a bit more, but ultimately there won't be any remainder left. For example, if you do 7 by 8, what will happen? So you are dividing 7 with 8. Okay. So let's do that. So again there will be 0, this is 0 point, and 8 ja 64. So this will be 6 remainder. After that we can put a 0 on that, and then it is 8 7 ja 56. Then there will be 4 remaining, and we could put another 0. And it is 8 5 ja 40, and after that there is no remainder. So this is also terminating because remainder is 0, and the value of 7 by 8 can be written as 0.875. Okay. So this is one type of rational number which is terminating. Now, is there only way of identifying whether a rational number is terminating or non-terminating just by dividing that? No, there is another alternative also. What is that alternative? That alternative is that whether we can express the denominator in the form of 2 to the power n multiplied by 5 to the power n. Let's understand what that means. Okay. Let's take the example of a rational number 7 by 80. Now, in this case, I am not dividing 7 by 80, but I am trying to identify whether there is any alternate way to find whether this would be a terminating rational number. Any composite number can be expressed in the form of prime numbers. Let's try expressing a t in terms of prime numbers. Start with 2, 2 is the first prime number. So this is 40, again 2 is 20, again 2 is 10, again 2 is 5. So what you find is that 80 can be expressed as 2 to the power 4 multiplied by 5 to the power What does that mean? That the denominator 80 can be expressed in the form of 2 to the power m multiplied by 5 to the power m. Therefore, 7 by 80 ultimately will be a terminating rational number. And as we can see, if you divide also, you will find the 7 by 80 will be equal to 0.0875. And finally, there is no remainder left. So it is a terminating rational number. Okay. Now let's talk about the non-terminating and recurring rational numbers. So rational numbers of this form, the remainder, when you divide the numerator by denominator, remainder will never become 0. It means it is non-terminating. But the unique part of this kind of rational number is that the numbers which come in the quotient, that start getting repeated. And that's the reason it is non-terminating but recurring. Let's take one example, like 1 by 3. So if you divide 1 with 3, then this will be 0.3. First 3 numerals will come. 3 3s are 9, so this is 1. Again you put a 0, again it is 3. Then again 3 3s are 9, 1, again 0. So what you are finding? That 1 by 3 will be appearing as 0.333. So this is the case of non-terminating, because it is not terminating. The remainder is never 0. Every time the remainder is coming as 1. Okay. And the number in the quotient is getting repeated. So this is non-terminating, recurring kind of rational number. Okay. There is one unique way. If suppose it is given in the form of p by q, you can do the division and you can get in the decimal form. The reverse is also true. You can get the decimal form converted into p by q form. How do we do that? For example, let's take the same example of 0.333. Suppose this is x and that is equal to 0.33. It is non-terminating and recurring because 3 is getting repeated. Now, the trick here when we are converting a non-terminating recurring rational number into p by q form, you multiply this entire, suppose you consider this as an equation 1, then you multiply this with that multiple of 10, which will bring the decimal 1 or 2 point away where the repetition starts. For example, if I multiply this with 10, this becomes 10x, the entire equation I multiply with 10. So this part will become 10x. This part will become 3.333, and because it is ever repeating, so 3 will get repeated. That becomes equation number 2. Now, if I subtract equation number 2 with equation number 1, what we get? This is 10x, 3.333, and this is x, which is equal to 0.333 and non-terminating, repeating. And we are subtracting, so this will be a subtraction. So this side becomes 9x, this side becomes 3.0000. Now you understand that why we have multiplied it by 10, because the moment you multiply by 10, there will be 3 here, but after the decimal point again the repetitions are happening. So when you subtract, the decimal point number will become 0, or rest of the numbers will become 0, maybe 1 or 2 numbers may be coming again depending on what number has been taken. But the whole idea is that you multiply x with that multiple of 10, which will move the decimal to a level where the repetition starts, so that when you subtract, the rest of the numbers will become 0. Okay. Now, then I can write 9x is equal to 3, and therefore x will be equal to 3 by 9, and therefore it is 1 by 3. So now you see that this decimal form of non-terminating recurring rational number has been converted into p by q form, which was 1 by 3. Okay. Now, there are then irrational numbers. Irrational numbers are those numbers which cannot be written in the form of p by q. Whatever effort you do, they cannot be written in the form of p by q. So those numbers are irrational numbers. And the unique characteristic of those irrational numbers are that they are non-terminating, non-recurring in nature. It means in the decimal form of the number, the numerals will not be repeated, and the decimal form is non-terminating also. It will keep on going and going and going. For example, take the example of root 2. Root 2 is an irrational number. The value of that has been calculated as 1.4142135 and on and on and on. Okay. Now, unique part is that you cannot find a pattern where the repetition is happening. Okay. So all these numbers will be coming in an order where you won't find any repetition happening. Likewise, pi 3.141592653, no repetition happening. Okay. Whereas in form of non-terminating recurring, after some point the repetition happens, that we have seen in the form of 1 by 3, where it is 0.333. Likewise, 1 by 7 is also non-terminating recurring kind of rational number, where you do the division of 1 by 7 and then you get 0.14252857, and after that repetition starts. So you start getting again 142857, 142857, and it continues. Okay. So these are non-terminating because they are not terminating, but they are recurring. 1.142857, and after that again the repetition happens. Contrasted with this, here these are non-recurring, non-terminating. Termination doesn't happen, remainder is never 0, or whatever value you calculate of the root 2, there won't be any termination, and the numbers are non-repeating. Therefore, these are non-terminating, non-recurring kind of numbers, and these numbers are called irrational. Now you can correlate that with a very simple daily life example. Suppose there are two friends, okay, and they want to go for breakfast. One friend says that I want to have maybe aloo paratha today in the breakfast. Another friend says, no, aloo paratha is not good, let's have puri sabji. But then I said, no, I'm not feeling like taking puri sabji, let's go aloo paratha. The other friend agrees, right? So their discussion terminated, they agreed for this, okay. Suppose next day they want to go for a movie. One friend says that, okay, I want to go for a Shah Rukh Khan movie. Other friend says that, no, yaar, I don't like Shah Rukh Khan. Shah Rukh Khan is overacting every time. I don't like. But the other friend says, no, but his movies are doing so well. He's such a great actor. He has produced such good movies and all. And whatever kind of movies he does, he just puts his life into it and make that movie memorable. So many hits he has given. So I just love it. Some to and fro, and finally they agree that, okay, fine, I differ that Shah Rukh Khan is a great actor. You say that yes, Shah Rukh Khan is a great actor. Let's go have a movie. But next time, we will have some other. So they live with it. So non-terminating, a recurring kind of character. But still they are rational. Okay. But let's take this example. This example, non-terminating, non-recurring, irrational, is the relationship of Sas and Bahu, mother-in-law, daughter-in-law. They will never agree to any one point, and the Sas-Bahu quarrel is time immemorial, going on, non-terminating, non-recurring, never-ending. If daughter-in-law says that today let's make maybe dosa and sambar in breakfast, mother-in-law will say, dosa sambar, it becomes so heavy. Why should we have dosa sambar? Let's have idli, so light thing. My daughter-in-law will say, light thing? Whole life you will eat only light things. Why can't you have dosa sambar also? That's so tasty. The kids like it. Kids, you are spoiling the kids. Okay? And this discussion and things keep going, never ending. Non-terminating, non-recurring, no agreement. So this is the example of irrational. Okay? I hope you have understood what is rational, what are the two types of rational numbers, what are irrational numbers, and with this example, why this relationship of two friends is a rational relationship, whereas mother-in-law, daughter-in-law relationship is irrational relationship. Thank you.